This question appeared in NEET PG 2022 and it asks you to identify a Lineweaver plot. And the options given in this question are A. Competitive inhibition, B. Non-competitive inhibition, C. Allosteric inhibition, and D. Suicide inhibition. Thank you for clicking to watch this video. There is a very important announcement. We have just launched our NEET PG previous year question bank in a book format which is available on Amazon. Just go and check the description to know more about it. Now, Lineweaver plot, enzyme inhibition, these are very critical topics, and not only they are critical topics but most of my students will find it very difficult. So the moment they will see this question, they will leave it or mark it wrong. So in next 5 minutes, I'm going to tell you a very easy method to identify any Lineweaver plot. Any Lineweaver plot, any type of enzyme inhibition, you will not have to anything to memorize. Just by basic concept, you will be able to identify any Lineweaver plot. So let's start it. Okay, so whenever you are talking about inhibitions, remember, let's create a 2 by 2 matrix. Okay, so if we talk about enzyme inhibitors, they can be acting on the active site. Okay, we know that every enzyme will have an active site, or they will be acting on the allosteric site. Okay, so enzyme inhibition, the enzyme inhibitor is acting on the active site or allosteric site, and the type of inhibition can be reversible, okay, or irreversible. Okay, right? So in this column we have got any enzyme inhibitor which acts on the active site but it's reversible in nature. In this column, okay, in this box, we have got any inhibitor which acts on the allosteric site but is reversible. In this box, we have got any inhibition which is active on the active site but is irreversible, and here we have got any inhibitor which acts on the allosteric site but is irreversible. So these 4 boxes are clear. Once you have these 4 boxes clear, let's put what type of inhibition falls in which category. So the first is enzyme inhibitors which act on the active site and are reversible in nature. Any guesses? Very easy to know. This is we called as competitive inhibition. Easy. What about inhibitions which act on the active site but are irreversible in nature? So these inhibitors will go and act on the active site and they will not leave. They are irreversible. So this is called as suicide inhibition. Let's talk about this inhibition which acts on the allosteric site but is reversible in nature. So this is called as allosteric inhibition. And the last category, what are the inhibition which will act on the allosteric site but is irreversible in nature? So this is called as non-competitive inhibition. Very clear. Let's put in the 5th category, and 5th category I will put it in the center. This is called as uncompetitive inhibition. What is uncompetitive inhibition? Here the inhibitor does not attack the enzyme. It attacks only the enzyme substrate complex. It does not attack the enzyme. It attacks only when the enzyme substrate are bind together, then only it attacks. Okay, so now we have got it. Now is the key concept which I am going to tell you. And this, if you remember, any Lineweaver plot, any enzyme inhibition related question, you will be easily able to solve it. So remember, whenever something is going to act on the active site, okay, anything, okay, so in that case what is going to happen? The enzyme substrate interaction will be affected, and so the Km value will be affected. So anything which acts on the active site, okay, so in that case what is going to happen? Okay, if it is not acting, so the Km value will remain constant. So for all the inhibitors which are acting on the allosteric site, Km value will be not changed. Okay, Km value will be not changed. Okay, so what about this? So in this case, when something is attacking on the active site but it's a reversible, so in this case the Km value will be increased. What does that mean? That the affinity of the substrate and the enzyme will be decreased. And in suicide inhibition, the Km value will be decreased, which means that actually the enzyme and the substrate affinity is increasing. Why? Because any reversible reaction, if you see A plus B is, let's say, forming AB, okay? If this is being inhibited, the reaction will be moved in the forward direction. And so, which means the reaction will increase. So here the inhibition is happening, okay, right? But so reaction will move in the forward direction, and that is why we will have the Km value being decreased in suicide inhibition, right? Now let's talk about anything which is reversible and irreversible. Anything which is reversible, remember, Vmax will not change. Vmax will not change. Anything which is irreversible, Vmax will decrease. Vmax will decrease. If you remember this particular concept, okay, that Vmax is depending if the inhibitor is reversible or irreversible, and Km is depending if it is acting on the active site and allosterate site. Now you can solve any question. Let's get to the question, and I'm solving you this question, but you can take any question and solve it with ease. So here you see the Km. If Km is not changing, 1 by Km also will not change. Okay, so we are talking about an enzyme inhibition which is acting on the allosteric side because the Km is not changing. Okay, so this removes competitive and suicide inhibition out of the equation. Okay, now imagine Vmax is 1 by Vmax is increasing. 1 by Vmax is increasing. This is 1 by Vmax. So Vmax is decreasing because remember y-intercept is 1 by Vmax. So 1 by Vmax, if it is increasing, this is without inhibitor, this is with inhibitor. So with inhibitor, 1 by Vmax is more. So Vmax will be decreasing. Okay. So if Vmax is decreasing, we know it is non-competitive inhibitor because in allosteric inhibition, the Vmax will not change. Vmax will not change. So the correct answer here will be V, non-competitive inhibition. If we have to draw the normal curve, so remember what is going to happen. So this is without inhibitor and with inhibitor. So without inhibitor, let's say this is the Km value. So with inhibitor, you will have a new curve where the Km value will be remaining the same, okay, but the Vmax will decrease. Any kind of graph, any kind of linear Lineweaver plot you can answer by remembering just one concept. If the inhibitor is acting as a reversible or irreversible. If it is irreversible, Vmax will come down. If it is reversible, Vmax will be not changed. And if it is, then the next concept is if it is acting on the allosteric site or active site. Whenever it is acting on the allosteric site, Km value will not change. If it is acting on the active site, depending upon if the Km value is increased, then it is called as competitive inhibition. If the Km value is decreased, it is suicide inhibition. So this video, if you just revise it once or twice, you will be able to solve any question on enzyme inhibition with confidence. Any question, any chart which is given to you.